In the last video, you learned how to solve quadratic equations like this by using what we call factoring and the zero product property. So first, you use your factoring skills to get it in this form of x minus 5 times the quantity x plus 2 equals 0. And then using the zero product property, you realize the answers will be 5 and negative 2. Well, what if there was an equation that wasn't factorable? What could you do to actually solve for x? That's what this video is all about. Let's get it on! First of all, what does it mean for an equation to not be factorable? Well, what it means is if you attempt to factor it using the box and diamond method that we have here, you put in x squared and 5, you multiply those together to get 5x squared, and then you need a sum of 10x, and you think, well, what multiplies to be 5? Well, it's only 1 and 5. Well, 1 and 5 doesn't add up to be 10, so factoring in is not going to happen here. You're going to have to come up with another method. And yet, when you go ahead and graph it, you'll notice that there are two x-intercepts. So there are solutions to this, but unfortunately, factoring is not going to get us that answer. So then the question becomes, well, what do you do? Well, there's another method you could use called completing the square. And this is how it works. Well, first of all, think about a square in general. What does that mean? It means that we have a four-sided figure where all the sides are equal. And what we're going to do this method is we are going to go ahead and we're going to take x squared like we usually do, put it down here in the corner, and then we're going to split the x term in half. So half of positive 10x would be 5x, and the other 5x would go over here. So why do you do that? Well, the reason actually is really simple, because if you think about a square, once again, it's a four-sided figure with four equal sides. X times x is x squared. X times 5 is 5x, and then same thing up here. This is also going to be a plus 5. So what we have here is we have a length and the width here of this being exactly the same. It's a square. Well, if we were going to complete the square, what we would need is 5 times 5 is 25. Well, we don't have 25 up here. We have 5. So now you have to think to yourself, well, what could I do to 5 to make it into 25? I'm going to have to add on a number. Well, if I add on 20, I'm going to get 25. Well, as we know when we solve equations, if you do it to one side, you definitely got to do it to the other. So now I have to add on 0. 0 is going to become 0 plus 20. So now we end up getting x squared plus 10x plus 25 equals 20. So here's why we want to do this. We can write the area of this as x squared plus 10x plus 25 because that's what's inside the boxes here. Or we can write it as length times width. So I can write it as x plus 5 times x plus 5. And then, of course, it still equals 20. And then, as we know, anything times itself is that term or number squared. So I can write this as x plus 5 quantity squared equals 20. And then finally, to solve this here, what we're going to need to do is we're going to need to go ahead and square root both sides. So I'm going to go ahead and do that right now. Squaring and square rooting undo each other, so we're left with x plus 5 on this side, and on the other side we're always going to get plus or minus, so it's going to be either plus square root 20 or minus square root 20. And you know, if we were to square root 20, we're not going to get a whole number, and that's okay. And then the final step would be subtracting 5 and subtracting 5, so we get x equals negative 5 plus or minus square root 20. All right, then that would be what we call the exact answer. And you can simplify this root. We're not going to right now. We're just going to leave it as such. But if you take your calculator out right now and actually punch in negative 5 plus square root 20, and you do negative 5 minus square root 20, you will get the x-intercepts that were shown on the graph. One of them is negative 0.53, and then the other answer would be negative 9.47. So this is a method you can use if it's not factorable. There are some limitations to this that make it a little more difficult. First of all, it's only x squared. If it had been like 5x squared or 3x squared or something other than 1x squared, it makes things a little more difficult. Also, 10 is an even number. If it's odd, like 7 or 11 or something like that, it doesn't make it super hard to do, but what it does is when you take a number like 11, you get 5.5 and 5.5. And so that makes it a little more difficult in terms of the numbers here. So usually I only use this when I have an even number in front of x and it's x squared. If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to the show. I'm going to give you the chance to see if you can successfully complete the square on your own. The equation is x squared minus 12x minus 3 equals 0. Go ahead, pause the video, and try this problem on your own. All right, so now that you've had a chance to try this on your own, let me show you what I did. First of all, I took the x squared, put it down here in the box. I cut 12x in half, or actually it's negative 12x. So I got negative 6x and negative 6x. I got x minus 6 and x minus 6 along the outside, which means I need a 36 to complete the square. Because you currently have a negative 3 but need a 36, to get from negative 3 on the number line up to 36, you're going to have to add 39. So I added 39 to both sides. Over here in the yellow, I got x squared minus 12x plus 36 is 39. I wrote it as x minus 6 quantity squared equals 39. Square rooted both sides, added 6. And so the exact answer is 6 plus or minus the square root of 39. And if you put it into your calculator, you should get the approximate answers of 12.24, and the other one would be negative 0.24. So I hope you got a lot out of this video in how to complete the square. There is a third in this series coming up here. It's about the quadratic formula. So hope you stick around and watch that video too. Thanks.